All right, Ben, so what did we discover this last week?
Well, after we talked here last week about, I don't remember, functions and classes, types, and instantiating things, we did a little research and came to some interesting new conclusions. So today we're going to clarify some of the things we said last week about factories. That's right, object factories.
Correct.
And we're going to talk about prototypes and classes, how to actually use prototypes and prototypal inheritance.
Correct.
Then we'll talk about how JavaScript got it all wrong. And then we'll talk about how to fix it.
Well, they got it right, but then they got it wrong, right?
So it was a good idea.
There's some great ideas, and there were some really not good ideas.
Yeah.
So let's talk about those things.
So it was a pretty fun week talking about this stuff.
Well, we really discovered that we didn't know. Honestly, I thought that I knew how prototype inheritance worked, and I thought I had it down. But the reality was I didn't, because the nature of JavaScript is confused about its origins.
Yeah, JavaScript doesn't know. I mean, Douglas Crockford says this. He says JavaScript is confused about its, what does he say, about its origins or whatever. Because the use of the new keyword flies totally in the face of prototypal inheritance, but you always hear people say JavaScript uses prototypal inheritance. It doesn't. Well, it does.
But it doesn't.
But you can't. But you can. So,
right. So let's talk about it. Let's talk about the steps that we went through, maybe. And let's figure out, because you came to me one night and you said, what is prototype inheritance supposed to look like, Ben? Let's talk about that.
Okay, we'll talk about the way prototypal inheritance was supposed to look in JavaScript.
And it makes sense this way, to me at least.
Yeah, that's what was happening. We were talking about prototypal inheritance, and I thought I understood it. So I said, "Oh, Jared, look, it works this way," and you said, "No, it doesn't." And we decided that it should, because we decided I was right.
Correct.
So all of prototypal inheritance revolves around the prototype. In a totally dynamic language like JavaScript, there's no such thing as a built-in type. There aren't any classes. So JavaScript doesn't know what anything is except for the built-in number, string, array, object, function.
So it's runtime. Like what we get is you have a set of base objects at runtime.
Right.
Your program runs from top to bottom as far as getting something declared, right?
Yeah.
And that's, well, oftentimes when I started out in JavaScript land, and C# confused me because classes, where did classes ever get built? I didn't understand it.
What's a class?
Well, it's a class. So what he's explaining is you really don't have a set of these hierarchy objects. There's not classes. It's, hey, you want to have something, you make it.
So
right?
if you want a car, you need to tell the language what a car is, and you do that by making an object. You actually instantiate a new object.
Mm-hmm. You
call it a car. So we'll say car equals, and then you decide everything that a car has. A car has speed.
Color. Let's do color.
It has color, and we'll say type. Well, wheels. We'll say how many wheels does a car have, and so you'll make this object and set it with some default values. Speed is 0 because it stopped. The color is black, like Henry Ford would make, and then most cars have 4 wheels. So when you want to make a new car, what you do is you use this car as the prototype, the cookie cutter, so to speak, of every new car.
So you're basically saying, if I understand correctly, is you're saying that you basically need to have, if you want another car, why rewrite this again? Because you'd have to go through all these steps once again to create this object. But you want to say, hey, this is my foundation.
Mm-hmm.
I don't have to rewrite this every time.
I know that every car I make, whether it's a Mazda or a Honda or a Land Rover, is going to inherit these properties of the car. That's the thing that every car has in common.
Okay.
Is the stuff that's in the prototype.
So make another type. So extend the prototype with another type of or specific type of car, I guess you would say.
Okay, so we'll
How would you extend car?
We'll say a Ford better be more specific, an escort has, boy, that's going way back. Not going to do an escort. We'll say a focus.
There we go.
A Ford Focus is going to have all of these things in common. So the first thing I do is say, I want to make a new Ford Focus, and its prototype is a car. So everything that a car has, my Ford Focus has.
So maybe we should draw the arrow going the other way. Saying, if it's not here, find it up above.
Okay,
Is that what you're saying?
So we'll say, we need to add a property.
But we should have thought of something that we could add properties on the fly. Let's say doors. How many doors?
Okay, doors. My car has 4 doors. So I have a Ford Focus. It has a prototype of a car. This Ford Focus has all of these properties. If I go ask it how many doors it has, it'll start here and say, oh, you've got 4 doors. If I ask my Focus how many wheels it has, it'll say, oh, I don't know here, I better check the prototype. Oh, the prototype says you have 4 wheels.
Correct.
Or if I say my Focus is blue, it'll start here. What color is your Focus? Blue.
Okay, so it stops right there at the first one.
Yeah, the prototype has a color on it, but the car doesn't.
Right.
So
really these what you described here aren't even necessarily instances. They could be. But it seems to me like this is a car prototype, this is a Ford Focus prototype. This is where it hit me when we were talking about this. Is I noticed, I forgot that this is where even though you want an instance of a Ford Focus, you really just want to do, you just really want this to be the prototype right away. Is that not right? So you're saying, hey, I want another, so if you want a Focus 1, right, it equals, I want to say Ford Focus. So how would I want all of that stuff. So here's my empty object, but I want to point back to yours. So now if I've hooked my prototype chain, I could have a Ford Focus with no additional data, and everything just points back to these two. Is that correct?
right.
And now this really becomes the instance. That's what's so beautiful about the prototyping is it's not like a classical inheritance. Then you could say Focus 2 is another, here's my empty box, but I point this back to here as well. So those two share these objects
Right.
as their prototype.
And the cool thing is having the prototype be an actual instance of an object.
You can augment it on the fly.
Yeah, let's say a new model year came out and every Focus came with a sunroof.
There you go.
So if I put a sunroof on the Ford Focus prototype, these automatically have sunroofs.
So even though I created them earlier, they will have it, won't they?
Yep, it'll be there because the language is going to say, do you have a sunroof property? No. Well, I better check with your prototype. Do you have a sunroof property? Yeah.
Wow.
So you could say, do you have an ejection seat property? No. Do you? No. Do you? No. Only when it's hit here, the last prototype, and not found the property, is it going to say that property is undefined.
So that's how it climbs the prototype chain.
Now look at this. There's more than one kind of Ford Focus out there. We could say Focus SEL,
Oh, there you go.
the trim package, and this adds
A spoiler.
a spoiler, yes.
How do you spell that? Looks good.
And then we can make instances of our SEL and link it that way.
So what's really neat is, so these share the prototype chain this way, and these share it this way. So these aren't a prototype of the Focus SEL, they're just a Ford Focus.
Right. But these are an SEL. And then if you were really crazy, you could actually turn this into a prototype and
Correct.
make copies of that. So that, if you know anything about classical inheritance, that seems like madness. But it's I don't know, it's pretty liberating. You get to define your types on the fly, and you know.
So I want to actually focus on the reasons why this is so brilliant, and one of the keys I think to the success of the web is jQuery and its ability to be adaptable. So let's talk about jQuery. So remember this, keep this in your mind, or I'm going to erase it, but we're going to talk about how jQuery works just in relation to this, because what they do is they don't go this deep with jQuery, but they use the prototype object to its fullest extent, to the point where it can't be used anymore. I mean, only so much namespace you can do. So I think that is why jQuery took off, is because somebody finally harnessed the power of the prototype object, right?
Yeah, and
So,
actually,
go ahead.
I think it may have been actually before jQuery. Remember the prototype?
The prototype
framework?
Prototype, yes.
That's why it's called prototype, because of
They
what-
used it,
what
right?
we're going to talk about here.
So,
Fire away.
so jQuery's object, if you look at it, should do it the right way though. jQuery's object is like this. It has the object, it's a function, so that's why you can do this. So this jQuery object that's a function has what?
It's got properties.
Has properties. So it has properties, but it also has
It
prototype.
also has a prototype.
Because it's a function. So now that it's a function, I could say jQuery.prototype, and then let's see what's one that they have built in. For example, I use this one today. Fade out. That would return you a function that jQuery's put on there. Now the way that they've done, they thought that this was a little bit silly, so what they did is they said, well, really, instead of that being so verbose, let's say jQuery fn is equal to jQuery. So they just alias the prototype. So now it's shorter, now it's more, people like this because, ooh, if I want to add functionality, all I have to do is augment jQuery, so people that build plugins know where this is coming from. They have a slightly different model and how you augment it now, but when its origin started, you could say jQuery blow up, and this you could equal to a function, and now what happens? Everything that was an instance of a jQuery that's out there now has blow up on it. So this may only be one deep, but it was being used to its fullest extent as far as that prototype was really being augmented on the fly.
Yeah.
And that is why it was so malleable and usable, is because plugins could just be on the fly put on and it wouldn't break.
So when you use jQuery, you'll put a selector in here. What does it give you back?
A jQuery instance.
An instance of jQuery. So you could say, when you say jQuery h1, you've invoked jQuery, you got a jQuery instance back. So anything that's on the prototype, or jQuery.fn, that's why you can use that stuff. Here you can say blow up.
Correct.
And if you write your plugin appropriately, where it's chainable, you just keep passing back, returning jQuery instances, and every jQuery instance that gets returned has all of this magic. And so this, that's genius.
It is.
To just extend the thing itself.
So this model can be compared into C# and other languages as extension methods in C#, because you're augmenting that base class with functionality. But what's even more liberating is we're not dealing with classes here. We're just dealing with objects. And you can have all of this functionality with prototype inheritance. So let's go through the prototype chain. I think we described the prototype chain pretty well, but let's go through the problems with to discuss
JavaScript?
with JavaScript. Well, we ran it because we created kind of a if you look on TypeScript, they have a great implementation of how to do classes. So if you go on there, play typescriptlang.org and go to the play section, you'll have a translator, and if you extend one of those classes, you'll see how they extend to classes.
And we're working on a website. When we have one, maybe next week we'll be able to announce the unveiling of our website.
There we
But
go.
when we have one, we'll have all this stuff in there, so you can Just kind of a reference to dig around and see.
But
So should we?
yeah, go ahead. So with that part there is it's really kind of weird what they have to do to keep this instance of alive, basically.
Let's talk about what's happening under the hood
Okay.
in JavaScript.
Okay.
And then it will be clear why all of this has to happen. I think you better do this because I'm not sure I even understand it yet.
There's some really goofy parts. So let's talk about the new operator first.
Yes, let's make a new something.
Okay, so if we want, let's do a new array, new object just for an example. So if we were to say var o equals new object, this creates an instance of object, right?
Yeah, this is the JavaScript base object.
Correct.
Nothing fancy.
Nothing fancy. So we're saying, hey, we want to instantiate this new keyword. What it does is it executes this function in the scope of the object and guarantees that it returns the instance, but it also hooks this prototype thing up, right?
So we talked about this, I don't know, maybe just to
Constructor
recap real
too.
quick. I think we talked about this.
Yeah.
What new is essentially doing is say var o equals, this is a bad example to use object.
Yeah.
It'll make sense. Var o equals an object.
Maybe we should do
And then
car.
we say object. Maybe
Dot
we should
apply.
do-
Yeah, let's do car,
Yeah, okay.
because that would make more sense. We'll just do car.
Now remember, car is a function that
Right.
we've defined somewhere. Okay. So what new is going to do is going to make a new empty object, and then it will say car dot apply in the scope of O, and then that gives you your new car. This is what we talked about last week, I think. It actually does a little more than that, which Jared's going to explain now.
So what it does is it actually tells the instance its constructor. Well, it doesn't. It tells it basically in the background. It doesn't even give you the opportunity. It's the prototype chain, basically. It says this car is hooked up. So if you said O, so if I went O.constructor, this should be that, right? It's not guaranteed. And it gets a little weird.
Yeah, maybe explain another way. When you make a new object, it does this, but it also gives your instance a prototype.
Correct.
Because every object has to have a prototype.
Correct.
So it makes sure that the O is linked up with the right prototype.
But it does that through the constructor. This is where it gets weird, because you can't say O.prototype. That gets you nothing. That doesn't even exist.
Right.
What's hard to understand is this actually exists in the background in interpreters.
In a prototypally inherited language implemented correctly, the O would have a prototype. For some reason, JavaScript hides this prototype property
Through the constructor.
behind the constructor, which you would think is the function, the constructor function, that you called to make your new car.
Correct. But here's where it gets a little weird. So I'm gonna type out how I'd write car and the problems that come with writing a very simple car. So a constructor. And let's say we wanted to let's do car first and then extend it with Mazda again. And I'll explain how the constructor and the prototype get muddied up really quick.
Okay, while you're doing that, I'm going to draw what a prototypally inherited structure should look like.
So you can beat the other person, right?
I'm just drawing a picture. No, we gotta go further out than that. You might beat me.
I always use Mazda because that was the first car that I ever owned.
Mine was an AMC Gremlin,
Well, there you go.
1975. It was green.
So I'm here and I've written a car class. Well, let's call this, it's really considered the constructor. because we're going to use it as such. This is just where it gets really screwy. And I'll explain that in just a minute. So when I declare a car function, this function object, so if I were to say car.prototype.constructor, what should that say, Ben? This is where I get confused. Well, I know what it says, but it doesn't make any sense.
It should be the car function, I think.
It is the car function, but that's where it gets really screwy, is because now that's kind of
That's a circular reference.
a circular reference. So it's saying, hey, the prototype, I don't know what the purpose of this was yet. I've yet to really understand why they put the constructor right there. So when you do this, write out a function of car and say car.prototype.constructor, you'll get car back. Okay, that's without doing anything. So the same principle applies when I do a Mazda. Well, here's the weird thing. Remember, if I were to say Mazda, this is going to be a good example. You can try this at home. If I were to say Mazda.prototype, because it is a function.
Mazda here is the type. It's not an instance of a Mazda. It's
Correct.
The constructor.
It's so this is, for every function has a prototype object on it. When you create this function, this is where we really realize some stuff, is the function, the object that's here, automatically gets this prototype object on it.
Right.
It then also has a constructor.
I don't know why they used long words like prototype and
And
constructor.
constructor. Well, this is going to feed you, that's going to output Mazda. Because what's going to happen here is you've got the same case as before as prototype.constructor. Well, if you want to inherit this, if you want to make this inherit something, what do? Well, this is how they tell you to do it. Let me tell you how it jacks things all up. So you say, I want my Mazda prototype to inherit from a car. So we're going to say the Mazda prototype is a new car, right? Doesn't that make sense? We want it to be a new car.
Right, because prototypes are instances of an object.
All right, so, well, here's what the problem is. This prototype object that used to be up here, right?
Mm-hmm.
So we said that the dot constructor was a Mazda. What happens now that we assign the new car to this prototype? Now let's output Mazda prototype again to the console. And dot constructor, this is going to throw you for a loop because you think that this should be maintained by the language.
You would hope, because the Mazda's prototype is an instance of a car, and an instance of a car's constructor is a car function, right?
So now we're actually going to have car. So before we made it inherit from a car, we now have it. We now have the Mazda. It returned to Mazda, not returned to car, because this new car is an object.
Uh-huh.
It can't find constructor on that object, so it goes where?
Up the prototype.
Up the prototype chain. What's the next prototype chain? We go to the prototype of car, which now has a constructor of the car. So this gets really screwy. Now you can't really know. So if you go deeper, for example.
Oh no, this actually makes sense. What doesn't make sense is
Is the
when you
next one.
make an instance of a Mazda and you say your
Yeah, dot
Mazda's
constructor,
instance,
correct.
Dot constructor.
Correct. That's
Which you
true.
would think would put you back here, and then you say the constructor's prototype,
Okay,
which
let's
you
do that.
think is the instance.
You're right. You're right. So if we said var m, right?
I was
Equals a new-
okay to this point. I could have accepted life and been happy with everything if we'd stopped here.
But we got here, and what did we say here? We said m dot constructor.
Can we still see that? Yeah, we're good.
Okay, sorry. Hope we can.
So now M is an instance of a Mazda, which is a function whose prototype is an instance of a car, which is a function.
Right. But now, if we say Mazda, we want to know what you are. Where did you come from? What does it tell us?
Well, I would hope that if you made a new Mazda, my constructor would be a Mazda.
So maybe in that constructor we're talking about the apply method, maybe what they forgot to do in this new operator is to maintain the constructor.
But yeah, this is important. Does this seem wrong to anyone else? That the Mazda, it's an instance of a Mazda. Why in the world is its constructor not a Mazda?
It makes no sense. And that's the problem, and you cannot climb up. You're stuck. Because every time that you go up, so let's say we actually maintain this ourselves, constructor. What we want the constructor to be a Mazda, right? This is our constructor, and we maintain that. The problem is even here, how do we get to the prototype of Mazda? So of the prototype of, so if we went Mazda,
Mazda's
prototype.
our type. That should be
how would that
car.
work? So you'd have a Mazda. So this is all self-discovery here.
Oh.
The cleaning lady.
It's after hours.
So the Mazda here, what would be the how do we get back? We have to always maintain this constructor in our constructor up here. So we have to say something like this dot constructor for this to all work correctly, right? Or would it work correctly? I have no idea.
So we were talking about the goofy things that TypeScript does to maintain all of this. This is the reason. And it's not just TypeScript. I've seen this pretty much anywhere. jQuery guy, what's his name?
John Ressig.
John Ressig. He has a recipe for doing inheritance correctly. And doing inheritance correctly means ignoring what JavaScript wants to do and pretty much doing it yourself.
Making yourself, wiring it up yourself basically, right? Because now we have to babysit the constructor on the instances.
So here's, and maybe we should say that the reason you would want to maintain all of this stuff is so that you can use the instance of operator. So you can say, is Mazda, or is M an instance of Mazda? That should be true. Is M an instance of car?
Right.
That should be true too. And if
Right.
you do it this way, it ends up being
Working.
correct.
But the problem is what we found is we couldn't, without all this crazy mess, we couldn't correctly hop up to find out, okay, a Mazda inherits from a car, which inherits from an object.
Yeah.
And we ended up having, because we have a bunch of POCOs, and we have an ORM on our JavaScript side, and we wanted to implement all these relationships. Let's say the car had some relationships, and the Mazda had relationships, but they're different, but they inherit. Those relationships should be inherited.
Mm-hmm.
We couldn't implement that very well, because we tried to climb up this prototype chain, and guess what? It didn't work. If we used the implementation they use in TypeScript, and we'd said object.constructor.prototype.constructor.prototype was always the same object. It was stuck in a loop.
You can't go up the chain. And I realized that while you do see prototype stuff in JavaScript pretty frequently, you never see it more than one level deep.
Correct.
It's always the array prototype, or the object prototype, or the element prototype. You never see it any more deep than that, and this is why. And the revelation.
Well, and this is the other problem too. Is what I figured out is when you do this, what if you have arguments you need to pass to there? This doesn't solve the problem of a constructor, because now you're passing. What if there's requisite? You have like required arguments.
Mm-hmm.
This doesn't work. Now you're passing undefined, and if you have to have something, dependency injection, which is a good thing,
Mm-hmm.
you can't do it in JavaScript, this type of model.
Yeah, and the problem comes down to this, in my opinion.
Okay.
New and constructor, these are concepts borrowed not from prototypal inheritance, but from classical inheritance, and they've leaked their way into this model and broken it. Over here, we've got our pure prototypal chain. What JavaScript has tried to do is break that and introduce this concept of a constructor. So you can't go from a type to a type to a type. You have to go from a type
To a function.
a constructor to a type to a constructor to a type. And if that were allowed, I would be even okay. But you can't even do that.
Because you get stuck in this cycle.
You walk to this far, and you just keep getting back. And
Yep. It just goes after this one deep, you get stuck right here.
Yeah.
And boy, is it annoying. So,
Yes.
with that being said, what we've discovered,
That is why JavaScript is broken, but not anymore. I mean, it is all this stuff is still in JavaScript. You can use it and shoot your feet off all you want. But
correct.
what we've decided, I guess this is our opinion, if this is the wrong way to do it, and if you're living in a world newer than Internet Explorer 8.
You should live in the world we're about to explain.
There's a better way. So I'm going to get rid of this.
And I have to admit, when Ben came and explained to me this, to his discovery about object.create and the beauty of it, I was like, wow, that makes sense.
That is correct.
That is the way it should be, because I always had this impression that I need to say new. I need a new something. I need something new. And I couldn't get away from this. And with
New means a constructor means classical inheritance.
and it also means functions, which don't make sense with constructors, and there's where the confusion starts.
Yeah.
So if we just avoid all of that, it doesn't mean that you can't use some kind. This is what's interesting. Let's talk about. I want to say how you can actually use prototype inheritance with a somewhat kind of initialized function on your objects. Like if you need something to happen, if you need dependency injection in JavaScript, you can do it through a function. It just shouldn't be a constructor, so to speak. It should be just a function that you call on an object to set it up.
Mm-hmm.
And that's where that's
more of a factor.
More of a factor. It's more like, hey, get me started
It's
here.
a configurator.
Yeah, it just get me running. So let's talk about it. Should we show? Well, let's see. Let me look at the screen here, and let's talk briefly about what we discussed here. We did a person, so let's do a person and an employee. This is a really good example. So we have a person object.
We want to define a new kind of thing, but instead of making a function to define the thing, we're actually going to make a thing.
We're just going to make
for crying
a person.
out loud.
And but what we're going to do is we're going to clarify our objectives by naming things correctly. So we're going to call this a person prototype. Because a person prototype has some things in it, right?
Mm-hmm.
And the things that we're interested in is it has a first name. Let's do first name and last name to keep it simple. Oh, let's just do null too. And last name. And then let's end that. Well, now this makes sense. We have a person prototype or just a person object.
Yeah.
But we want to clarify that we're going to use this for
But
more
hang
than
on.
just a person.
Where's your constructor? Don't you need a constructor to make a person?
Nope. We don't. We can just make an object and stick it there. So this is the object literal that we love so much. All of us have loved this because it's just like on the fly, dynamic, create the object, wow.
We did call this person Adam because every other person is going to come out
There you go.
of this person.
There, exactly. That's a wonderful example. So let's extend that and make an employee prototype.
Okay.
But what we want, because let's make it Jared. Let's make somebody and say, hey, I really would like to have a person. So I'm gonna name this object Jared. Make it so we know what we're talking about, and say I want to say that Jared's template, right?
Mm-hmm.
Jared's prototype really is object. This is what you should be using. .create, and it's the person prototype.
Now you're thinking that's really more verbose and annoying than just saying new person with a function. But the thing this does is actually set the prototype chain up correctly.
So if I were to say now in the language today, in not because it was ECMAScript 5 that we got the
Yeah, it's 1.3.5.
what does that get prototype of, I think?
Yeah.
So you can say I want to know if object dot get prototype of all these verbose, you love that, don't you?
Mm-hmm.
Get the prototype of Jared. The beautiful thing is it returns person prototype. That makes sense, doesn't it? Because that's what we used to make the instance of Jared. Now the great thing is down here we could add more things to Jared. We could say Jared dot
Hair color.
hair color is rat colored brown. so you have hair color equals brown. And that's fine because these objects are dynamic and they can just keep going.
And that doesn't affect the prototype at all.
Yeah, it doesn't affect this.
And I know I've beat this horse to death, but it's just amazing to me. When you get, say, object get prototype of Jared, you're actually getting back this object, it's an instance of an object. It's not a class. It's not some type of thing defined somewhere. It is a thing that exists.
And it's right there.
You could play around with this if you wanted and mess up all of the other people in the world. But it's the thing. Okay.
So now let's
Carry on.
carry on. So I'm going to take this out. Now that you know that we could create instances of just the person, right?
Right.
Of people.
But I need a more specific kind of person.
So we want to, like, what's important for our company is employees. So we work with this a lot. So we're going to say we want to create an employee prototype because we've got lots of employees and we need to make sure that we can create instances of them.
Yes.
So we're going to say, hey, let's create a cookie cutter, so to speak, of what employee prototype is. But we do know that, hey, some of this is already made for us.
An
So we're gonna,
employee is a person.
it's a person. So we just say simply object.create. We pass it in the person. I should have named that something shorter, but tough luck, Jared. Prototype. Now we've made that employee prototype. We can then say that what's great about this is this. We can. I'm going to talk about the second parameter on that in just a minute, but we can do it the old way. So let's do it the old way.
Go ahead and extend our employee.
So with the employee prototype,
You can,
what's that? What you laughing for? Now I'm
oh,
curious.
I was blaming the standards people for using long names, and now Jared, who has a choice, still chooses
The long names.
the employee prototype.
Because I really like declarative stuff. I guess when I'm typing, I don't care so much. But man, when you're on the whiteboard, it gets pretty verbose. So employee prototype, we want to add. Let's do like
Hire date.
hire date. That's a good idea. And we'll just equal that to null for now because this is just a prototype, right?
It's not any employee in particular. It's
So it's just we're just kind of setting up the fields, so to speak. So now at this point, let's just break this off right here. We've created now an employee prototype. Somewhere down the line, 1 million lines later, okay. This is how we create that's a lot of.
That's too many lines for one source file, Jared. You should really think about abstracting that.
You're right. That was a bad programming model. So we should probably create some better reusable code if we have 1,000 lines later. But regardless, let's say we now can say I want to create an instance of an employee. So let's say Ben now is an employee, and we say we want to create an employee, but we just want an employee prototype. So let's just go object dot create. We're going to use the employee prototype as the template. Employee prototype. And now we've got Ben. The beautiful thing is this. If we went again and said object.get prototype of Ben, that will return us. So if right here I'm going to say that's going to return us the employee prototype. So right here. But if we then say it again, I guess we have to wrap it. So let's do this.
Good luck.
Gosh dang. Well, let's do this. Let's do this way. We can just say object it again in here. Get. So right here, you'll understand in just a minute. Prototype of Ben. That right there would return a person. So that would then return the person prototype. That is a thing of beauty because now you see that model that Ben is drawing up right now makes perfect sense.
I am one of these. One of these
is one of those. And now at any time we can come up here sometime later and say, boy, what should we add to the employee prototype? What's important to us today? How about the terminate date? Right?
Yep.
Terminate date. We'll just equal that to null because it's non-specific. And now we've got the terminate date equal to null. And mind you, we're just doing properties, but this is where the most power comes from our methods.
You put functions on here. Oh, yes.
It just really unlocks your world. So I told Ben, we should never, ever, ever see new again. And we should never even care to say instance of. So we created a function.
Yes, we should say that instance of totally falls apart down here because instance of wants an instance and a constructor. Remember that evil thing?
The two stupid things that don't
shouldn't
make any
be
sense.
using at all. So it wants a type for an instance, and that there's no such thing as a type. Our types are objects.
So let's use them.
So instance of doesn't work.
So now that we completely have gotten rid of, we've gotten rid of the reason for instance of, well now we can actually climb the prototype chain here, like Ben is diagrammed here.
We need to be able to say, is Ben a person?
Correct. So how, in our implementation, I guess we could check on code, what we'd really say is we'd say, what did we put this on?
We put it on the object.
Yeah, that's what I thought. But somebody might get mad, but that's tough.
Don't tell Alfred.
There you go. So we said has prototype, right? So it's not actually on the prototype, it's actually on the object itself, the function of the object.
Right.
So has prototype, and then you pass it bin, and then,
And it would be the person prototype.
and we want to see if it's a person, right? Person prototype. That right there would return true. So now our life is wonderful because now we not only have a way to go up the hierarchy accurately and not cyclically in an infinite cycle,
Yeah.
we actually can say, hey, we just want to know if this thing is a person. Just let us know. And so that function becomes quite helpful. But this here is a work of art. This is the way JavaScript should be used. And it's sad that we don't. And even in ECMAScript 6, I'll be honest, I was really excited about classes coming in about a month ago.
Mm-hmm.
And now that I know how to use JavaScript, I'm a little bit depressed that we've gone that route. Because now people are going to get confused again. They're going to use instance of, and they're going to somehow wire all this junk in the background to somehow work. But it's confused about its nature and who it is and how it works.
But on some level, that's actually okay.
Because we can avoid it?
Because we don't have to use it if we don't want to. The beautiful thing about JavaScript is that it's, in so many ways, it's unopinionated about how you should be designing your program. It's possible to make a prototypally, even a badly implemented prototype inherited language like JavaScript, emulate a classical inheritance model.
Yeah.
It's far more difficult to make a classical model inherit.
Or look or act like a prototype model.
So JavaScript can be whatever you want.
Correct.
And so having class in ECMA 6 is okay, and it's going to make a lot of people who want to be classically, or want to use that classical model, really happy. What's sad is that this prototype paradigm is so powerful and so beautiful, and it's pretty much just going to be forgotten about.
Maybe not if Douglas Crawford has a word to say about it. He'll make sure to his dying breath that this exists. But
we won't, and you won't. We should note that get prototype of and object create, I think.
Yep.
Are
native.
they are native as of
Was it ECMAScript 5 that we decided?
IE9.
And all the other browsers.
I think it's funny. Nobody cares what the standard is. It's just like how far back in IE can you go?
IE9.
This is an IE9 feature, and everybody else.
That's a given, right? So they don't even say that. Just IE9
IE9
means IE9 and everybody else.
So with the death of XP, in what, 3 months?
Oh, let's hope it's sooner.
Then you'll be able to do this all you want.
And I think that's pretty much it.
Yeah.
Do you have anything else to say?
Yeah, we could have talked about emulating a classical model, but that's far too code intensive. Maybe we'll post a how-to about that.
And then it gets really confusing, and I still haven't quite figured out, other than having the constructor be assigned to the function that it's a constructor in the constructor,
yeah.
any way to get out of that cyclical.
And because of that, I would say if you want to be classically inherited in JavaScript, don't even try to use any of the built-in stuff. Like instance, forget about instance of.
Yeah.
Do your own. And then that's actually what we ended up doing. We put a constructor and a parent constructor property on these objects that we were.
On the prototype, so that the prototype would know, all the
Yeah.
instances would share, hey, my superclass is this and my class is this. My super constructor
Yeah.
and my constructor are these
Constructor
two
super-
things.
We did, instead of
Trying to get all the
anytime you see
prototyping.
this, anybody try to implement, there's like 6 or 7 lines of unreadable JavaScript that's trying to hook everything up the way it doesn't want to be hooked up. So I would say just forget about it.
Yep.
And start over.
And use TypeScript. There you go.
And then, sorry, one more note. From my understanding, ECMA 6 doesn't actually have classes. It's emulating it using, like under the hood, they're going to emulate classes
With prototype.
with these hacks that like TypeScript does and stuff like that. So really, you're better off just doing this.
I
That's the
agree.
moral of the story.
Well,
The end.
the end.
See you next week.